Good morning, ladies and gentlemen. It's an honor to have the opportunity to address such as distinguished audience. Thank you for listening. My name is Soualmia. I'm a PhD in electronic field. The purpose of today's presentation is to discuss double-thread induction generator based wind power generation system with P and Q control. First point, let's start with the introduction. The aim of this work is to present the complete modeling and simulation of wind turbine driving double-thread induction generator, which feeds AC power to the utility grid. For that, to pulse within moderate voltage source. Converters are connected back-to-back between the rotor terminals and utility grid via common DC link. The grid side converter controls the power flow between DC and bus and the AC side and allow the system to be operated in sub-synchronous and super-synchronous mode of operation. The proper rotor excitation is provided by the machine side converter. Wind power as an important and promising renewable resource is widely studied. Recently, double-thread induction generator becomes more popular in wind power due to its various advantages over other types of wind turbines, such as variable speed, low power electronic, cost, and so on. In this work, first of all, the dynamic model of the basic wind power system is driven in complex form. Based on the dynamic model, a complete control strategy is presented to control the rotor side converter and grid side converter respectively. The complete control method, which is capable of separating the axis and Q-axis components of rotor current, is applied to harness wind power. The concept of instantaneous power is introduced to regulate DC link voltage. The complete system is modeled and simulated using PC software package. Moving now to the next point. Defining wind power system model. The description of the system. We have got here the whole of the system that contains the wind turbine and the feed and the converter back to back and its control. So here is the control strategy. So the wind generation system starts in this work consists of two components: the double-thread induction generator and the variable speed wind turbine. A detailed description of these two components is given below. The DFIG might be regarded as a slip ring induction machine whose stator winding is directly connected to the grid and whose rotor winding is connected to the grid through the directional frequency converter using back-to-back PWM voltage source converter. The electrical part of the DFIG is represented by four overstate space model, which is constructed using synchronous rotating reference frame, while the axis is oriented along the stator flux vector position. The relation between the two phase quantities and the Q components is defined by Parkes transformation. The voltage equation of the DFIG are mentioned in equation number 1, whereas the active and reactive stator and rotor power is given by equation 2. So, moving to the third point, which represent the main results of our work or our simulation. So the figure 2 represents the wind speed, the figure 3 represents the DC link voltage, whereas the figure 4 of the last figure represents the stator voltage evaluation. Conclusion. In this work, the modeling and control of variable speed with system based on the fixed system is presented wind power, which is distributed generation is capable of supplying alternate current of electricity distribution network. The wind energy production system is modeled and simulated using BISIM software. To analyze the performance of the wind system, a scenario of normal condition was applied to the result of simulation, demonstrate that active and reactive powers of the wind system can be independently controlled with granting optimal active power supplied to the system. Thank you for your attention.